This is from exam 2, and I'm going to go over the questions that were graded as a part of your assignment. I'm going to start with question number 1. Question number 1 is asking you to factor this. There's several ways you can do this. The first way we're going to do this is by taking a look at the graph of it, and we'll notice that we have a 0 at x equals 6, which means that x minus 6 is a linear factor. From here, we can use synthetic division to find other factors and set it up. You're going to pull out the variables and just have coefficients. You're going to divide by the 0 of the function, and it's a process of multiplying and adding the two all the way across, if you recall. And so as a result, we end up with a 0 as a remainder, which confirms that 6 is a factor, but then we have to remember what to do with that 3, 1, 1. We're going to throw the variables back into the equation, and that gives us the quadratic. And as a result, now we're going to take a look at it to see if it can be factored. And upon inspection, it's irreducible, which means it's non-factorable. And now we're finished. All we have to do is write it as a function and leave it just as factors. Let's move on to the next question, which is question number 5. You're asked to find the range of this particular square root function, and you have a couple options. One is to use your graphing calculator to look at the highest and the lowest y values on the graph, but you should also have a pretty good knowledge of transformations. And the general template of this shows us that it has been reflected over the y-axis as a result of this negative, and then it's been shifted to the left 8 and up 3. This up 3 part is really what we want to focus in on, because that's going to determine the floor of the graph. As you recall, the x-axis of the parent function is the floor of the graph, so it's been moved up 3, then that's where the new floor is. So we're finished with this graph, and the range of the function is going to be 3 to infinity. The next question concerns limits, and this is question number 8. And as you recall, limits are determined by intended heights. So in the first part of this, we're asked to find the limit as x travels from the left. Where's it headed towards? Where's this pen headed towards? And as you can see, it's headed towards -2, this -2 value. In like manner, as you take your pen and go from the right and follow along this path, where's my pen intending to go? As you can see, it's intending to go to -7. So that is the answer to these two questions. Now the limit without the directional arrows would indicate that there is no limit, because if there was a limit, then your intended height should be the same coming from both directions. All right, let's take a look at the next question, which is number 10. You're asked to list the horizontal asymptotes. So remember, you have to take a look at the degree of the equations. And the degree of the equation is by comparing the degree of the numerator with the degree of the denominator. You can see that the denominator has a larger number. So as a result of that, then we know that the horizontal asymptote is at y equals 0. And this is just something that you have to have memorized. Let's look at the next question. We're asked to test the graph for even, odd, or neither. And as we look at it, we see it's a polynomial function by definition. And polynomial functions, you can look at the degree of the equation to determine whether or not it is a candidate for even or odd. Now, because the highest degree of this is at 4, then we are going to come to the realization that we're not going to need to test it for an odd function. So, meaning if it's an even function, that just simply means that it is symmetrical to the y-axis. So if I draw an xy grid and have a point in the first quadrant and I fold it along the y-axis right here, then the point will show up over here in the second quadrant. You'll notice that the x is negative and the y is positive. So when you plug in a negative x into the original function, then the outcome should be the original function because the y's did not change their signs. They're both positive. All right, so let's do the test. And as I plug in negative x and then reevaluate, I notice that I did not wind up with the same equation as I started with. It's pretty close, but this right here was the disqualifier because in the original function it was a positive. Therefore, this function is neither even nor odd. Okay, let's take a look at the next question, which is number 19. You are asked to find out where this function is less than 0. Now, we have looked at this, and in the context that we looked at this is in terms of the domain, but in like manner we can still do it without it asking for domain. So first thing you want to do is to factor it. They want us to do this algebraically, so we're going to use the number line, and our zeros are going to be at -2 and 5. So we're going to test each region to figure out the sign. If I test it at -3, my outcome is a positive. If I test it at 0, then my outcome is a negative. If I test it at after 5, then my output is a positive. And so the region in which this parabola is negative, in other words, where it falls below the x-axis, is between -2 and 5. And that is how you would answer that question. So you can put it in interval notation, or you can write it as an inequality. Let's move on to the next question. Now this one is asking for the domain, and the denominator has been factored. So the first thing we need to do is take a look at the numerator because we have that radical, which means that whatever is sitting underneath that radical, when I plug in a value for x, it has to be a positive number or equal to 0. Therefore, x is going to be greater than or equal to -5. Then if I look at the denominator, I can see that I have two x values that would create a 0 or an undefined fraction. And those two values are at -3 and 4. Now what I have to do is to merge all of these. Now you could actually leave your answer like this, but if you're writing an interval notation, you could merge it, which means you're going to start at -5, travel to -3, jump over the -3, travel to 4, jump over the 4, and then off to infinity you go. And that would be the answer. Okay? The next question is asking us to state the degree of the equation and the leading coefficient. Now this one is slightly tricky because it's not in order. So you have to write it in descending order. And as a result of that, we see that the leading coefficient is 1 and the degree is 9. And some of you added these coefficients together, and let me just give you the context of that. If you were asked to find, let's just say you had a function, and it had factors in it of two variables, and I asked you to state the degree of that, this is where you're going to add the coefficients, and it would be a fifth degree equation. But don't do it when there's pluses, when it's terms involved. Just go by the highest degree. This is a polynomial function. It is odd. If you add the exponents together, you're going to get 18, and so you're actually changing it from an odd function to an even function by doing that. All right, let's move on to the next question, which is a multiple choice question. I believe it's question number, should be 29. I see a number 2 up there, but I think it should be 29. And you are asked to pick from 4 choices. Now first, let's take a look at this. The end behavior follows the trend of a line with a negative slope. So look at your answer choices and disqualify the answers that don't have a leading coefficient that's negative. That would be multiple choice B and C. Then what you want to do is check the y-intercepts of your other 2 answer choices, A and D. When you plug a 0 in for x, you're going to get a 12, positive 12, and that matches letter D. So D is the correct answer. Okay, the next question is question number 32. It's about a bunch of mosquitoes and rainfall, and you're asked to find out how much rainfall would you need or would max out the number of mosquitoes. And so without having a graphing utility in front of me right now, I'm just going to factor it, find the zeros, and graph it. As you can see, it has a 0 at x equals 0. It has a 0 at 16. And I went halfway between the parabola to find the vertex, and then plugged in the 8 to get the 64. Now, the answer was 8. Excuse me, let's go back to that. The answer was 8 because the question was posed, how many inches of rain? I had 8 million on some of those answers, and so be careful about how you label that. It would be 64 million mosquitoes from 8 inches of rain. Okay, so let's move on to the next question, which is find the inverse and then state the domain. Now, what we can do is we can simplify this. We don't have to, but we can. It just kind of makes it a little bit easier to work with. As you can see, both the numerator and denominator have a common factor of 3 that can be canceled out. So our new equivalent equation is this right here. And now what we want to do is we want to switch, back it up. We want to state the domain of this equation and the range. Because once we take its inverse, we've got to switch these out as well. Now, the range, if you recall, you learned how to do that by looking at the graphing calculator and finding out where the lowest point was and the highest point was. But recently, we've been talking about horizontal asymptotes, which would in essence be the floor or the ceiling of the graph that we're talking about. So if we take a look at the degree of both the numerator and denominator, it ties. And so y equals 3/2 happens to be the horizontal asymptote. So this is the line that the graph will never touch. Now is the time to start switching out those variables and switching out your domain and range. Cross multiply. Do this little cross multiplication and get this equation right here. Then what you're going to have to do is distribute your x. And now what you want to do is you want to take anything with a y in it and put it on one side of the equation, and anything that doesn't have a y in it, and put those two together. So as you can see, that's what I did. Then the next thing I can do is I can factor out a y. And now I'm almost done. I can divide through by 3 minus 2x to get this answer right here. Now there are equivalent forms of this answer, depending on what side you pulled your x's and y's to. And we do need to remember that the the domain of this function is the old range of the former function, so x cannot equal 3/2. All right, the last question is write a polynomial function with these zeros. Now I added the fact that we had to add the imaginary zeros common conjugate pairs. That's from the imaginary root theorem, and so we added that. Now this part I want to explain. When you put this back into factored form, you have to be real careful about putting these in parentheses, because the template for factors is x minus a, and a is the 0 of the function. So that's why we had to add these parentheses right here. As a result of that, now we can remove the parentheses and we have a trinomial times a trinomial. I want you to do those trinomials first, because what happens is all of the imaginary units disappear as a result. So you can set it up as a grid as I've shown you here, and what you're going to do is just find the area of each of these grids, as you can see that I've done. And now you can eliminate your inverses. You have a pair of opposites right there, another pair right there, and we know that I squared can be converted to a -1. And so my trinomial as a result of that is going to be this right here. I'm not finished. I have to do this one more time with the x minus 4. So again, you can set the grid up. You don't have to do this grid thing. You can do it just by distributing, but this is a good visual for those of you who are strugglers. So at any rate, so you can fill that in and then gather up like terms, and your final answer is given. Now make sure that you put this f of x here, because it is asking you to put it in polynomial form. And that does conclude this video, and I hope it was helpful. If you have any questions, come see me during in period.